This is section 14.1 about absolute extrema. And so we know how to do the derivatives now, and we're going to do some application type things here. So we need to remember what an absolute min and an absolute max is. If you are looking at a picture, it's usually it's pretty easy to see. Here is the absolute max. Now, on a continuous function, f, on a closed interval from a to b, you will have both an absolute max and a min. And that should make sense. You got two endpoints. There's going to be a high point. There's going to be a low point on that closed interval. Now we have some steps, and these are important for finding the absolute extrema using our calculus. So number one, find all the critical numbers. We know how to do that. We take the derivative, we set it equal to 0. And then we're going to evaluate f for all critical numbers. That means we'll take those critical numbers, plug them into the f function. And we'll evaluate f also for the endpoints of the interval. So if it says over a to b, we're going to evaluate at a and at b and the critical points. The largest value found in step 2 or 3 is the absolute max, and the smallest value is the absolute min. So let's see what that looks like when we're doing our problems. All right, number one is going to be probably a pull-down menu in your actual homework question. It just says identify the labeled point. Is it either an absolute min, absolute max, or neither? And so for this one right here, it is at the top. You're going from increase to decrease. That's an absolute max. Identify each point in number 2. So x1, that is the highest point in this interval. That's an absolute max. x4 is the lowest. That's an absolute min. And these two are neither absolute maxes or mins. All right. Now, number 3, we get to where we get to do the work to find the mins or maxes. So here is our function. Here is our interval. And you're asked to put in the absolute max value is blank. That's a y value at an x value. And then the min down here. So first thing is, here's our function. We're going to take the derivative. The derivative of this is 3x squared minus 4x minus 15. We're going to set that equal to 0. We're going to factor it, and that's set equal to 0 still. You take that factor with it equal to 0, that factor, it equal to 0, and you solve for x. So we got x is negative 5/3 and x is 3. Now, the x is 3 is not in this interval. This interval is only from negative 2 to 0. So we discard that and we only use this critical number. So I would suggest drawing a box like this and have your x values and then your y values that you will calculate. So your x is negative 2 and 0. Those are the values of your interval, and negative 5/3 falls right there. And so you're plugging those in to your original function, and you're getting values here. And the largest of those is the max, the smallest is the min. They do want fraction numbers, so you'll have to change that to a fraction. Now, there's maybe another little trick to help you in doing this on the calculator. Okay, so I pulled up my calculator here, and I went to y equals, and I put this in here. So where we're plugging these in is in the original, so I put the original there. Now, if I go to second and the window key, there's the way I want my table set up. So if you want to use this, you need to make sure that ask is dark here on the independent row and auto is dark here. Not really important for this stuff. And so then second, quit out of that. Just do that one time. Now we'll go to second, table. I'm going to delete all of those things out of there so that we start fresh. So I want to put in these three that we have here. A -2, enter. A -5 divided by 3, enter. And then a 0, and enter. So that did all the calculation work for me. And so I've got my answers. You know, that's what's written right here. Now, the only other thing we need to do, let me quit out of that. Second quit. Okay. If I type 19.81, let's see if that'll change fraction for us. So that didn't quite get it. I don't remember what the other one, what that was. Let me go back to the table. 19.815. Let's try that. 19.815. And math and fraction. That didn't do it for us either. Okay. Let me think on that for just a second and we'll see. Okay, so I could not convert that on the calculator, and since it's wanting it in fraction, I just went ahead and did this by hand, showing you how to get the 535 over 27. It's unfortunate that we couldn't do that the other way, but anyway, I just plugged this into the original, just kind of did it by hand as much as I could, and got common denominators here, and added across the top, and it's 27 over the bottom. So your answer is -5/3 and 535 over 27. So the y value, the f of x goes here, and the x would be the -5/3. And then for the min, you would have 5 at 0. So you would plug those in there. So let's look at number 4, same idea. Here is your original function, here is your interval. The derivative is -4x cubed plus 36x. We'll put that equal to 0. We'll factor out -4x. We're left with x squared minus 9. And so that's one factor where you get 0. And x squared minus 9 gives you a plus or minus 3. So now we have 3 critical numbers and our interval numbers. So I tried to put them in order. So I went -4, -3, 0, 3, 4. And you're going to plug those in to the original. And it looks like these are all whole numbers. You could probably put it in your calculator and do it the way we did with the table, or just do all the plugging in. You have 2 that are the highest, that's the zeros, and -81 is the min. So when you're putting that in, the absolute max, you're going to have 2 of those. So I think you'll probably have -3, 0 and 3, 0, both of those there, and then the absolute min would be 0, -81. And so that's what would go in there. Number 5. And number 5, I did the work down here. I didn't have room. So number 5, here's our function. It is a quotient, and the interval is -2, 2. So if we go down here, we have our roadmap, the bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. Take the derivative here and you get 4. The derivative here, you get 2x. That's all that happened in that line. Then we start cleaning up. So 4 times that is 4x squared plus 4 minus 8x squared. Okay. Now, I combined these two, so I have -4x squared plus 4 over this. If you take that and set it equal to 0, the denominator is going to multiply over there to the 0 and be gone. So we just have this piece. Subtract 4 and then divide by the -4, so you get x squared is 1. So the square root of that would be plus or minus 1. So we have two critical numbers right here, and we have our interval -2 and 2. Plug those into the original. These are your y values. So you have a min at -1, -2, and a max at 1, 2. So that is the answer for number 5. Number 6, let's look at number 6. So in number 6, same idea, but our function has ln x over x to the 12th. And so we're going to take the derivative of that. I was trying to figure out what I had done. The problem changed, and so it is not a quotient in your homework. It looks more like this. So this is the example that we're going to do. So f of x equals x squared minus 200 ln x on the interval from 1 to 13. So the derivative of this is 2x minus, remember the derivative of ln x is 1 over x. So you have 200 over x. Now we're going to multiply by x to get that fraction removed. So if I multiply by x here, once I set that equal to 0, I've got 2x squared minus 200 equals 0. Add 200 to the other side, x squared is 100, and x then is plus or minus 10. So those are our critical numbers, and you have 1 and 13. So the -10 is discarded because we only start at 1. We don't have a negative over here. So we just have 1, and we have 10, and we have 13. And when you plug those in to the original, you get 1, you get -360.52, and you get -343.99. And they are allowing decimals, and they say round to 4 places. So your max is 1, your minimum is 360.52. So those are the values that go there. Your x values go in the second box, your y values go in the first one. So in number 7, we have the total profit in thousands of dollars, so that's important, from the sale of X 100,000 pillows is approximated by. So here is your profit function, and here is your domain restriction. X has to be greater than or equal to 5. Find the number of 100,000s of pillows that must be sold to maximize the profit, and find the max profit. So we're going to go down and do that one, I believe here, it's actually number 7. So let's just change that. And we'll make that a 7. Okay, so we have our profit function. We take the derivative of it. We get -3x squared plus 24x plus 99. I see that all of those are divisible by 3, so I'm going to divide by -3 all the way across. I'm left with x squared minus 8x minus 33 equals 0. That does factor to x minus 11 and x plus 3 equals 0. That gives me x is 11 and x is -3. But remember, our domain, x had to be bigger than or equal to 5. So the -3 is discarded. So the only thing we're worried about is 11. So we're double checking here. We're saying here is my critical number, and this is x less than 11, x is greater than 11. And I tested f prime of 10, f prime of 12, found that this was positive, this was negative. And so this is the max. 11 is the number that's going to give you the max. So 1010 is the max of the profit. And so if we move that decimal 3 places, we get our profit is this. And for the 11, remember that 11 was, how did they say it? 1,100,000 pillows. So if my X is 11, I've got to make it 100,000. So I've got to move that many decimal places, and that's how many pillows I have. So be sure that you put your answers, that you've moved your decimal places to get those. So those are going to be our answers there. Let's see how it asks for it. So the maximum profit is, and then you'll put the number of pillows sold there. So that's the pillows and that's the profit. All right, let's look at our last one. It is number 8. Find the minimum value, so minimum, of the average cost for the cost function of the given intervals. So this is a little bit, they throw a twist at us, average cost. So here is our cost function, and they want to know if x is between 1 and 10, and if x is between 10 and 20. So we have to find the average cost. All right, let's go here. So the cost function is here. And remember that cost, when you have something and you're taking the average, you divide by the number of items. So the average cost of X items is, and this little bar over here means average, you divide this whole thing by X. So if I divide X into that, I get X squared, X into that, I get 30, and then I have 128X. So since I need to take the derivative, I'm going to go ahead and write that piece as 128x to the negative 1. That's just going to make it easier. So the derivative is 2x, the 30 is gone, and this becomes negative 128x to the negative 2. And so then I can put it back in regular form. Instead of the x to the negative 2, I put the x squared on the bottom. So this is the derivative of my average cost function. All right, so I set that derivative equal to 0. I want to get rid of this, so I'm going to multiply everything by x squared. That becomes 2x cubed. The x squared is gone. I'm equal to 0. 2 divides over here into the 128, and I get x cubed is 64. That means the cube root of 64 is 4. So that is my critical number. So I have 1 and 4 and 10. I put those into, remember I'm putting in the average cost function, not up here, but rather here or here, either one. And I get these numbers. Well, my minimum is here, 4 and 78. Now, I've already done the 10, so I didn't have to figure that out. For the 10, 20, I just had to do the 20. And in this one, the 10 is the minimum. And I didn't have to do the 4 because it's not in the interval 10 to 20. So those are your answers for that one. So I think that'll give us good practice on Extrema and using our derivatives.